Okay, the scientist named Travis Oliphant has introduced Numpy in 2005. Numpy stands for Numerical Python. Now, it's a foundation library for scientific computing in Python. Since it provides data structures and high performance functions that the basic package of Python cannot provide. Okay, so what does it mean? Means it provides this numpy provides some data structures we will see later and high performance functions that the basic Python package cannot provide. Okay, so for that purpose, we should install this numpy library. So Python has many libraries, inbuilt packages. So last class I have detailed about what is a library, what is a package. Okay, so the standard Python has so many inbuilt packages, but this additional package, numerical Python, which we can install into the actual Python to make the Python somewhat more good for data science operation. Okay, so NumPy is a foundation library for scientific computing in Python since it provides data structures and high performance functions that the basic package of Python cannot provide. Now, NumPy defines a new data structure which is n-dimensional array in short form ND array. Okay, so the data structure provided by defined by the NumPy is known as ND array, n-dimensional array. It is mainly for array operations. Okay. Now NumPy is mainly for scientific computing with Python and especially for data analysis operations. Now that is about the numerical Python or simply known as NumPy. It provides a new data structure named ND array, n-dimensional array, and it provides more functionalities that the normal Python cannot provide. Okay, so that's all about numerical Python. Now, usually this NumPy will be installed along with the Python you have already installed. That means you, in according to me, if I am right, you have installed Python using Anaconda. I think so. Now, if you have installed Python using Anaconda, then this NumPy will be already pre-installed. It will come along with the Anaconda. So that's what I told you at the beginning. Anaconda is a distribution that provides the normal Python plus some additional packages like NumPy, and you will come to know about pandas in the next session or the following session. Okay, so you need not install this NumPy again. Now, if it is not installed due to some what to say, some problems, it has got damaged or the installation didn't happen properly. So, in that case, you can reinstall it again. You can install it again using this instruction pip install numpy. Usually, this is not required because, as I told you, the Anaconda will have the numpy. Okay, so no need to install numpy again. So if it is not installed, you can install it again using pip install numpy. Now this pip install means this is the usual procedure to install a package or a library. Now in case of numpy, it is numpy. In case of pandas, you have to use pip install pandas. Pandas is another package. We will see it later. Okay, we will see it later. Now this is the usual procedure to install NumPy. Last class I have shown you how to install using command window. I have told you once again I will show it here. You have to open the Anaconda prompts, ANA, the Anaconda prompt, then open the Anaconda prompt. Now, Anaconda prompt is similar to the command window. How will you open command window? Just by typing CMD. Similar to Anaconda prompt, you have to type CMD, command window. Okay, similar to that, you have Anaconda prompt here. So here, just by typing pip install numpy will install numpy for you. Now, when you click enter, it will download the numpy and will install for you. Now, since I have already installed or the Python I have, which is already having this numpy, so the requirements already satisfied, and I need not install the numpy again. Okay, if it is not installed, that numpy will be automatically download from the website, and it will be installed. Okay, so this is the way to install numpy. Now, how to check the version, that also I discuss. Now, go to Python, or here just by typing pip list, PIP, just by typing PIP, then LIST, pip list. That will give you all the packages we have installed. Now, I here have installed so many packages. In that, you just search for the NumPy. Yes, NumPy is already installed 1.24.3. Okay, then you can check the version in another method also, just by typing. You have to go to Python first, just by typing Python, Python. This will allow you to go to Python directly. When you press enter, it will show Python 3.11.4. Now you are inside the Python. Now you can access Python interpreter directly. Now just by typing the version, see numpy, numpy dot underscore version underscore will give you the version of the numpy. Uh, NumPy. Yeah, yeah. I have to first import NumPy. I have to first import NumPy. Import NumPy, because this NumPy is another external package. So we have to import it first into the Python we have now. So I have installed. Sorry, I have imported NumPy. Now you just type NumPy uh, dot underscore version underscore. See, it will give you the version. Okay, 1.24.3. So this, I think I have already explained, so I'm not taking that much time. Okay, now we have one more method, just by opening the Jupyter notebook. These things also are in my, I think I have already explained, but anyway, you open any Jupyter notebook. I am opening the one I have already saved. You can open a fresh notebook. I am here opening the one which I have already saved, NumPy, named NumPy. Now here just by um, okay, so here just by typing the same, first you have to import it. Import, import NumPy, then enter. then numpy dot underscore underscore version underscore underscore. When you execute this, uh, sorry, there is a spelling mistake. When you execute this, you will get the version. Okay. Now this version will not be shown if the numpy is not installed, and of course this import command also will not work if this numpy is not installed. Okay, so this is the way to understand whether numpy is there in your along with your Python or not. Okay, just I am just okay. I will keep it here itself. Let it be here itself. Okay, you can refer later. Now, how to import numpy? Just by typing import numpy, or we have one more method, import numpy as np. Now we are using a short name named, also named alias name. Okay, just a short name, because every time it is very difficult to type numpy again and again. So we are using a short name np here. Instead of this, you can use any other short code if you want. Okay, so I am just using np here. Usually this is the way to call numpy. Okay, import numpy as np. Now this is also okay, import numpy. Now if you import numpy like this, you have to use this numpy every time. So I will show you. But here you have to use only np for numpy. So that is the simplicity if you call the numpy like this. There is no other change. I will show it hands on. Okay, so listen here. This is the way to import numpy easily. Import numpy as np. Now from here onwards, whenever I need to use numpy, I can simply use this short name np. Okay, so that is the importance of using this np. Okay, now how to create? I told you the basic data structure in numpy is n dimensional array. We can have any dimension. Okay. Okay, so first of all, how to create a numpy array? How to create a numpy array? Now we have seen already how to create a list. For example, my list is equal to 1, 2, 3. Then, uh, so let me clear the output. First of all, I cleared all the outputs. I restarted the kernel. Then we will start it again. Okay, so we will start from here. I'm importing numpy. Just a second. Clear output. Restart and clear output. Okay, I will start from here. Import numpy as np. Then first of all, I will create a list named my list. So this is the list. Now when you see the type, it is a list. So this you know already. Then how we can convert this list into a numpy array? Say one dimensional array. Okay, so first of all, we are going to create a one dimensional array from a list. We have the list here already, 1, 2, 3. Now, this can be done by just a variable array is equal to, we have to call numpy first because we are going to create numpy array. Okay, so numpy we have already imported here. See, we have imported numpy as np. Now we can use np for numpy. See, array is equal to np dot. So inside that numpy package, you have a function named array. So that is the meaning of np.array. So inside the numpy, you have a function named array. So this array is to create nd array, n dimensional array. That's inside the numpy, we have a sub function or a function named array. The library or package means a collection of so many functions. Okay, so this array is one such function. We can make use of it to create numpy array. Now, just by passing that my list that we have already created here, see here, my list. Now, when you print that array, let us see what you are getting. So, we are getting an output array of 1, 2, 3. We are getting an output array 1, 2, 3. So, that means, see the output of the list. See, only 1, 2, 3. But here, see what is the difference? This is not a list, this is actually an array. Now let us see the type of the array by just typing type array. See, it is a n dimensional array. So what we have created just now here is it's an n dimensional array. It can be one dimensional, two dimensional, three dimensional. The type of the array is ND array. Dimension here it is a one dimensional array. Okay, so this is the way to create a simple one dimensional array from a list. Now, why I showed this list means we have already seen what is a list in our previous class. Now, just by passing that list into this function, we can create an array. So that is what I wanted to show to you. Just by passing that list to this function, we can create an n-dimensional array. So here it is a one-dimensional array. Similarly, we can create two-dimensional also. We will see later. Okay, so we are getting the type of the array is n-dimensional array. Now, this we have created from a list, my list. Now, if you don't have the list with us, how to create an array, a one-dimensional array? Assume that you don't have the array, you don't have the list with you. Then how will you create an array? Same method. You define the list within the array. Define a new list. Then just by typing this, see, you are getting the same array. It is a one-dimensional array. If you want, you can see the type. It is a one-dimensional array. Okay. Any doubt here? Usually, you will not be required to create an array. You will be given with an array. But this is just to show how to create an array. Okay. Then we will see how to create a two-dimensional array. Two-dimensional array. Use the same function np.array of we are going to create 2D array. So how we have created 1D array? See, just by passing the list. Now, if you want two dimensions, see, you pass one list, the first row, second list, comma, the second list, the second row. Okay, then it should be enclosed in a list, square brackets. So this is the way to create a two-dimensional array. Now, when you print the output, see, it is a two-dimensional. You have two rows. This is first row. This is the second row. Okay, so this is also a NumPy array. If you want, you can see the type of array 2. See, it is also NumPy ND array. So what is the dimension here? Two dimension. So this much only is required for us. One dimensional, two dimensional. Similarly, if you want, you can create a 3D, 4D also, but that is not, we will not be able to visualize that. So that is why I'm not creating those dimensions. Okay. Only 1D, 2D are required. Now, we have some keywords to be used, some methods to be used. from an array, what are the parameters we can get and what are the keywords for that. Okay, just now we have created array 1 and array 2. Now let us see the shape of the array. Shape means, see, now shape of array 1 dot shape will give you the shape of the array. Array 1 means it is a one dimensional array. How many elements are there? Three elements. Okay, it is a 1D array, three elements are there, so that is why it is showing 3. Comma, there is nothing because it is a 1D array. So let me see the shape of the second array we have created. See, it is 2, 3. So what is this 2, 3? See the second array, this array. See, this is the array 2. Two rows and three columns. Array 2, this is array 2. Array 2 contains two rows and three columns. So that is the thing we are getting here. Two rows, comma, three columns. Okay, so this is the output of this shape method. Okay, here what we are getting, one dimensional array, three elements we are getting. Only one row, three elements. Okay, that is the this is the way in which it shows it's a 1D array with three elements. Okay, this is two rows, three columns. Now we can reshape also. Now you are getting two rows and three columns. Now just you reshape that array. Array 2 dot reshape of 3 comma 2. It was previously 2 comma 3. Now you reshape it to 3 comma 2. It will work. See how many rows are there now? Two rows, sorry, three rows and two columns. Now this way we can reshape the array also. I think this is clear to you. Don't get confused. This 3 means number of elements. That means number of columns we can say. Here, if you want, you can say. But for all other cases, first one will be number of rows and the second one will be number of columns. For 1D array, this is the way in which it gives the output. Okay, that you can observe here straight away. Now, this is the way to reshape it. Now, if you want to know the size of the array, what is the size means? Number of elements in the array, you can use this array dot size. Now, we have the array here, array 2 we have here. How many elements are there in array 2? You can count from here. There are 6 elements. Let us see the output of this array 2 dot size is 6. Okay, size means the number of elements. Now, let us see what is the dimension. What is the dimension of this array? It is a 2D array. Okay, it is a 2D array. So, in order to see dimension, it is n dimension. It will give, it's a 2D array. Now, what is the type of the data you have used? Integer, because inside the array, we have used integer numbers 1, 2, 3, 4, 5, 6. So, like that. So, int 32 is the data type. Okay, so these are some methods we can, some properties of the, some, these are some of the properties of the array we have defined. Okay, any doubt up to this? How to create an n-dimensional array? Here 1D array, 2D array, and how to see the properties, the size, the dimension, the shape, other things too. Now here are some methods to create some. See, if you want to create an array of three zeros, so this is the way. See, this is floating point, 0.0.0. See, so that means floating point is allowed, but every elements are floating points. Okay, so this is the way to create three zeros. Now, if we want to create zeros 4 cross 4, see, 4 rows and 4 columns, that is 4 comma 4. You can create like this. So, if you want to create 5 cross 5, you replace this 4 comma 4 by 5 comma 5. That is enough. See, just by typing 6 6 6 4, 6 rows and 4 columns. That is possible. Np dot zeros of 6 comma 4. Okay, now np dot ones, that means we are creating numpy array with all ones. Now if you want a different size, 4 comma 4, same method, np dot ones 4 comma 4. Okay, now instead of this 0 and 1, if you want to give some other numbers, so this is the method. That means instead of this 1, I want to have all the elements 8, number 8. So this is the method. np dot full 3 comma 4, that means the size. This size can be any size, up to you. Now this is the number you want. See, it produces an array of size 3 cross 4 and the element is 8. Now if you want to have instead of 8 some 6, see, so this is the way to create uh, an array of all sixes. Okay, sorry. Now if you want to create an array with random numbers, okay, so we can have this function, rand, random function. Random function helps to initialize an array with random values. See, so for that you have to use the function inside numpy which is named random. Okay, so this is uh, a sub library we can say. So inside that we have many functions. See, this numpy is the main package. So inside that we have a sub. Random is a sub package we can say, or sub library we can say. Now inside that we have this rand function. So this rand function will generate random numbers. How many? 4. Okay. Now if we want size 4 by 3 or 4 cross 3, np dot rand 4 comma 3. Now when you execute it again, this will change. See, because these are random numbers. When you execute this each time, these numbers will get changed. See, you can see it here. When I'm executing it again, see, now it is 0.139. So these are random numbers. You can create an array having any number of rows and columns using this rand function. This rand function is there in the sub library uh, random. Okay. Now, as I told you earlier, you can reshape this too. See, this is the one already created. Now, using this reshape, you can also reshape it. See, np dot random dot rand dot reshape 6 comma 2. Okay, so when you do this, see, 6 rows and 2 columns. Now, instead of this, you can directly give it here, 6 comma 2. That is also possible. This instead of using this reshape, you can straight away give it here, no issue. But in order to show this reshape, I am just showing it here. Okay, I think you got my point. Random function inside this random inside this NP numpy. Now see, you are getting floating point numbers here. Now instead of this, you want integers. Now you have one more function inside the random. Main function is see main. The sub library is random here. Inside that we have used rand. Now instead of this rand, we can have rand int for integer values. Rand int. So this is similar to rand, but you will get integer number out selected randomly. Okay, let us see. Here we have created, we outputted only one number, which is between 1 and 100. So this is 28. Now if you execute it again, you will get a different number. That is why it is random. Now if you want it in a different shape, you can use this method. Between it should be between 1 and 100, and the shape should be 3 comma 4. See. Okay. Now one more important function which is inside the numpy is a range. So that means we can create numbers from, or we can create a one dimensional array having numbers from 0 to 10. Now you know that if you use this 0 to 10 in list and all, we have seen it will print numbers from 0 to 9 only, it will not print 10. Same way here too, see, it will produce an array of numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It will not print 10. It is similar to the list we have seen. This function is useful, a range function. See how many times we have used this NP here. So that is the importance of using an alias name for numpy. So instead of this, if I had used this numpy only, then you imagine how many times I should have typed this numpy. So in order to avoid that only, I have used this alias name or short name NP, because I should type that numpy again and again if we are not using this NP. So in order to get that advantage, I have typed this NP. That's now I think this arrange function is okay for you. Now in order to create, uh, see here it is np.arrange same 0 to 10 with a step size of 3. That means this 3 will be added. You can see what is the output, 0 to 10 with a step size of 3. That means 0 plus 3, it is 3. Okay, then plus 3, 6. Then plus 3, 9. So that is the step size that you can give. Now, where we can use this? Say, here is an example. Generate even numbers between 30 and 40. So this can be easily solved by using this. Generate even numbers between 30 and 40. So that means 40 should be included. So that means here np dot a range 30 to 41 you have to give. Then only we will get this 40. Otherwise it will stop at 39. So in order to avoid that, we should make it 41 here. So np dot a range 30 comma 41. Now you are asked to generate even numbers. So what is the first number generated here? It will be 30. Then plus 2, 32. Then plus 2, 34. So even numbers. So in order to get those even numbers, we are using step size here to see 30, 32, 34 up to 40. And for this purpose, we can make use of this arrange. So this is one application of the arrange function. Okay, any doubt here? Okay, so we will proceed. Now we have one more important function, linspace. Linspace. Linspac. Now we have already seen how to use a range. Now this is the format: starting a, stopping, np dot arrange, starting, comma, stopping, then a step size. So similar to that, we have one more function, linspace function. Okay, so here 0 is the starting point, 10 is the ending point, and this 3 is the number of samples required. Let us see. See how many samples we are getting here, how many values we are getting here. 0, then 5, then 10. Only 3 values. Now, if you change this to 4, see 0, 3.3, 6.6, 10. Okay, so that division will take place. That is the application of linspace. So here clearly I can specify how many values we can, how many values we require. You can clearly specify. If you want such a functionality, you use this linspace. Otherwise, you go for this range. That's it. Then one more example: np dot linspace 0 to 50, 50, and we require 10 values. This is the use of linspace function. Now here this 10 will be included. The stop value 10 will be included. So they have defined this function in that way only. We cannot change it. Okay. Now some mathematical operations on Numpy array. Okay, how to add two arrays. So for that purpose, I am defining a Numpy array, one dimensional array only for simplicity. See, I have defined a one dimensional array. Okay, so for this array, the elements 0 to 10, then see array plus array. See, array plus array means ARR plus ARR. The array will be added with itself. So elements 0 plus 0, 0, 1 plus 1, 2, 2 plus 2, 4. So like that you will get elements here. So this is the result of array plus array. Now array minus array, it will be 0. Now, in order to show that, I have just shown you this symbol array. Okay. Now, instead of this, you can create two arrays and add the results. Okay. Here I have one example. So here I have created two arrays, array A and array B. Okay. Now I am going to add. See, here I am using this add function. Instead of A plus B, I am just using add function. You can use A plus B also, no issue. See, if you add A plus B, see, this will work, no issue. So it is similar to what I have shown here, array plus array. This will work. Similar to that, here A plus B will work, and A minus B also will work. But here I am just showing one keyword add. So np dot add A comma B will give you the addition result. See, same result. Now similarly, you have np dot subtract A comma B subtraction result. You can verify it. Two arrays, 10 minus 1 means 9. 10 minus 1 means 9. So like that every elements. Okay, then you can find the power A power B. See A and B. A is 10. 10 power 1 is 10. So like that. Element by element. See 10 power 1 is 10. Similarly 15 to 225. Similarly for the other element too. Then you can multiply. NP dot multiply A comma B. See, first element will be 10, 10 into 1 because you know A and B elements, first elements are 10 and 1. See, here 10, here 1. So 10 into 1 will be 10. Similarly, 15 into 2. Next element. Result 30. See, so like that. Now, divide function also work. 10 by 1, it is 10. 15 by 2, it is 7.5. Similarly, for the other element. Okay. Now, this is how we will operate on arrays. We will have different operations on arrays. Okay. Now, round function. How to use round function? Now, assume that you have a Numpy array like this: 1.232, 4.67, 8.9889. You want to round the elements. See, you are getting 1. This 4.67 becomes 5, 8.98 becomes 9. Rounding function, round up. And similarly, you can round the above elements. See, number of elements required at the rounded output is 2. See here, how many element? How many? See, 1 point after point you have three values: 2, 3, 2, 3 digits. Okay, you want 2 digits only. The rounded number contains only 2 digits after the point. See, it was actually 1.232, it becomes 1.23. Now here it was 8.98889, it becomes 8.99. So like that, rounding happens. Rounding function. Then how to find minimum and maximum of elements? Now again one more array. I'm defining one more array here. See here how many rows are there? 3 rows and 1, 2, 3, 4 columns. See how to define: first row, first list; second row, second list; third row, third list. And these rows should be enclosed in a list, square bracket. Okay, you will get a 2D array like this with 3 rows and 4 columns. Okay, so assume that you have an array like this. Now I want to find out. See, this is new A. Array name is, that means this array I have moved to the variable or object new A, new underscore A. Now I want to find out the minimum value in this matrix. So I can use np.min of what is the matrix. Matrix is in new A. Okay, so this will give you 1. That means the minimum element is 1. Now, if you want to find the maximum, same method, np.max of new A. What is the maximum here? 87. Okay, so this is how we will use min and max. Now, one more thing you see here. So this min and max, by default, it will find out the minimum value of all the elements. Okay, now if you want to find out the minimum value in this particular column, first column is 1 4 27. Now you have to use it like this. Sorry, here it will give you, see, axis is equal to 0 means it is column wise. Axis is equal to 0 means it is column wise. So this will give you minimum values in all the columns. So what is the minimum value in first column? It is 1. What is the minimum value in second column? It is 2. See, first column minimum value is 1. Second column minimum value is 2. Third column minimum value it is 3. Fourth column minimum value it is 23. See, 23. Minimum values in all the columns because we have given the entire matrix here. And axis is equal to 0. Axis is equal to 0 means it denotes the column operation. You remember this point? Axis is equal to 0 means it is column operation. Now, axis is equal to 1, it is row wise operation. Now, if you give this, what you will get? Row wise, what is the minimum value? So, let us execute this. See, what is the minimum value in the first row? First row minimum value is 1. Second row minimum value is 4. Third row minimum value is 8. See, 1, 4, 8. Okay. Now, what is the mean value of the array elements? See, np.mean of new A. You will get the mean value 18.16666, etc. up to here. So, what is this value? This is the mean value or average value if you are taking using these elements. Among these, what is the average value? That is this 16.6, sorry, 18.166. Now, if you want to see the standard deviation, if you want to see the median, you can use these codes. Okay, so these things are self-explanatory. If you want to find mean, standard deviation, and the median, you can proceed in this way. Okay, any doubt? Now, see, let us see. We are defining. I am defining two arrays here. to one-dimensional arrays. Now, what will be the output of array 1 equal to array 2? What is this equal to? It will check whether these element by element, it will check these elements are equal or not. That means this 1 will be equal to 2. So let us see the output. See, is this 1 equal to 2? No, it is false. Is this 3 equal to 3? Yes, it is true. So like that, it will check element by element for the true false. See this one 6 and 5, it is false. Next one 9 9, it is true. Then 66 33, it is false. Okay. Now what will be this array 1 greater than 6? It will list element by element. See first one, it will take 1. 1 is greater than 6? No, false. Then it will take 3. 3 greater than 6? False. Okay. Then 6. 6 greater than 6? False. Then 9, 66 are greater than 6. So true, true. Okay. Now you have one more important function where. Okay. So see np dot where array 1 greater than 6. See what is the output? 3 comma 4. 3 comma 4 means 0, 1, 2, 3. So third index is 9 and fourth index is 66. That means in index location 3 and index position 4, we have elements. Those elements are greater than 6. So that means this where will give you the location, index location of elements corresponds to this operation. Okay, that's it. If those elements are greater than 6, it will show the locations of those corresponding elements here. 3 comma. Now concatenation. How will you concatenate two arrays? So this is the method defining two arrays A and B. Then np dot concatenate A comma B. See 10, 15, 35. Then 1, 2, 3. So this is the way to concatenate two arrays. Similarly, see here defining two uh, arrays new A, new B. Then concatenating new A, comma, new B. Okay, so let us see what is output here. And here see D is equal to np dot concatenate new A, new B, axis is equal to 1. So here I have written axis is equal to 0 by default. That means here it is axis equal to 0. Now, since axis is equal to 0 by default, we need not show it here. It is already axis is equal to 0. But here I want to include what is axis is equal to 1 row wise operation. So let us see the output. See, initially, what are these new A and new B? Let us visualize new A, new B. New A means 3 rows. 1, 2, 3, 4 column. Similarly, new B means again 3 rows four columns. Okay, 2D matrices. Now see concatenate A comma B means this is the output column wise because here axis is equal to here by default axis equal to 0. That means column wise operation. Now when you do that column wise operation, this is the output. So that means here is the first matrix 1, 2, 3, 23. See 1, 2, 3, 23. Then 4, 5, 16, 33. Then 27, 8, 9, 87. So this is the first matrix, new A. Now second matrix 1, 4, 3, 23. 1, 4, 3, 23. 4, 7, 16, 33. See this one. That means this is the second matrix. So the operation, concatenation operation, when we do with 2D matrices, by default it will be column wise operation. So that means, sorry, that means one matrix, then below that the next matrix, column wise operation. Okay, now if you want row wise operation, see like this is the first matrix up to this center 1, 2, 3, 23 up to this, then the next row, then the next row. This is one matrix, this is the next matrix. So like that, if you want an output like this, you need to use this concatenate new A new B axis is equal to 1. That's it. Because by default it is axis is equal to 0. If you want, you can check it out. That means if you give axis equal to 0 here, nothing will change. See, same first, second matrix. That means by default it is axis is equal to 0. That is why I have not included that axis is equal to 0 there. Okay. Now we have some more application, some more operations. You see it by yourself. It is self-explanatory. Horizontal stack. See, A and B. I am taking A, B here. Almost similar to column wise, row wise. See, A, B. What is A? What is B? Uh, where is A and B? Just a minute. Okay, here it is A 10, 15, 35. B is 1, 2, 3. Okay, so the same A and B I'm taking A comma B horizontal stack. That means see horizontally stacked 10, 15, 35, 1, 2, 3. It is similar to uh, this operation. Axis is equal to 1. Okay. Now this also you can try by yourself. Column stack A comma B. A will be the first column 10, 15, 35. See 10, A 10, 15, 35. B will be the second column 1, 2, 3 like that. Okay. Now the most important thing is indexing and slicing. So this is almost similar to the list we have seen already. Almost similar. Now I am defining a new numpy array here. So I'm just using arrange function 1 to 13 with step size 2. See 1 to 13. with the step size 2. So these are the array elements. Now instead of this, you can use any methods. You can define a list. You can use np dot array of that list. That is also okay, no issue. But I have defined the array in this way. Okay, you can define the array by first defining a list like this, my list, and just by passing that my list to array. This is also a method to define an array. So like that, I'm using here a range function. That's it. Now using that, I have defined an array here. Then similar to list, here too, the indexing start from zero. That means zero element, first element, zeroth indexed element, first indexed element, second indexed element, third indexed, fourth indexed, and the fifth indexed. Okay, so that means uh, it is similar to list we have seen. It starts from zero, ends at n minus one. Okay, so this is similar to what we have seen earlier. So I will show it here. Now, what is a of 3? Similar to list, what is a of 3 here? A of 3 means the third indexed element. What is the third indexed element here? 1 is first indexed, 3 is second indexed, 5 is third indexed. See, when I execute this, sorry, 1 is zeroth indexed, 3 is first indexed, 5 is second indexed, and 7 is third indexed. See, a of 3 is equal to 7. It starts from 0. Okay. Now, if you want to see what will be this a of 4 or 5, a of 5 will be 0, 1, 2, 3, 4, 5, 11. It is quite similar to the list we have seen, operations in list we have seen. Okay, it is a slicing method. Actually, we are just obtaining one single element. Now, same thing. Slicing means the same thing. We are just slicing out one single element. Okay, this is also known as slicing. Now, here I am explaining that slicing in detail. Now, here again I am defining the same list, sorry, same array. Now, I am taking the same third element, 7. Now, instead of that, if I want elements from first to third, what is the output? It is similar to list. First is 3, then second is 5. 3 will not be counted, third will not be counted. So 3, 5 will be the output. Sorry, here 1 to 4. 1 to 4 means 3, 5, 7. 3, 5, 7. 1 is 3, 2 is 5, 3 is 7. Only that much. Fourth will not be counted. Fourth means 9. See, here I have slightly mistaken. It is actually fourth. See, 1 to fourth it is shown here. It is 1 to fourth. That means 1 colon fourth is 1 to fourth. 1 colon 4. This is similar to the operation, the slicing operation list we have seen. Okay. So there I have explained. When I explained the list slicing, I explained the use of this colon. So this colon indicates 1 to 4. 4 will not be included. So that means 3, 5, 7. Same thing. Now assume that you have a two-dimensional array. Okay. Now here, what is this 1 2 3 means? So here, when we take the case of 2D array, so this 1 means the starting row and 3 means the ending row. So which is the first row? First row is this one only. So this is the zeroth row. So that is the numbering scheme we are following. Okay. So this is the zeroth indexed row. This is the first indexed and this is the second indexed. So 1 2 3 means starting from 1, not including 3. So that means only these two. Okay. Third row will not be there. There is no third row here. Here, zeroth row, first row, and second row only. So definitely this third row is not going to be there. But if I use this 2, what is the output? Only the first row because second row will not be included. That means this row will not be included. So that means it shows the center row only. So that's why it's shown here. In order to show two rows, I have just shown this 3 here. Okay, anyway, that 3 is not present there. Third row is not present there. Okay. Now, in most of the cases, machine learning cases also, now you will come across a situation in which you want third element of second row, third element of second row. So this is the way we have to use array 2D of 2. Of 2 means second row. Which is the second row? This is the second row. Okay, second indexed row actually. Now in that, what is the third element? Let us see. 87. We can see it here. This is the second row. In that, what is the third element? 0. 27 is 0. 8 is 1. 9 is 2. And 87 is 3. So 87 is the third element in second row. That's it. Now instead of this, if I am using 2, what is the output? 9. Okay. Second element of second row. Usually the thing is, uh, whenever we use index, the starting will be the zeroth. Now here too, we are using indexing only. So that's why this is the zeroth row, and this is the first column would be the zeroth column, zeroth indexed column. Okay, indexing is different. Starts from zero only. Don't get confused. Now you can see here that there are three rows, but the first row is zeroth indexed row. Similarly, here there are four columns. The first column will be the zeroth indexed column. Okay, so this is the second indexed row. So in that, this is the second element. Nine. Okay, now see the output of this 2 comma 3. Now this is similar to this operation. See here, uh, second row, third element. So similar to that, here also you can you have the another way 2 comma 3. Now when you use that comma here, before comma it will be the row, after comma it will be the column. Row comma column. So what is the output of this 2 comma 3? second row, third column. So that means which is the second row? Here, second row means this one. In that, which is the third column? Zeroth column. This is the first column. This is the second column, and this is the third column. Now it is correct. So this 2 comma 3 is going to be this 87.